Hello everyone, this is Lara Roman from the USDA Forest Service, Philadelphia Field Station. My research addresses the temporal dynamics of urban forest systems, which is to say how urban forests change over time. And this includes field-based monitoring of tree mortality and growth. Tree mortality is what I'll be talking about today. And I also study long-term tree cover change using aerial photography and do work in citizen science. But the focus of today is tree mortality. This can be a sort of depressing or morbid topic. When I was getting started in this research during graduate school, I got to know Greg McPherson, who's now retired from the Forest Service. He used to call me Dr. Death because of my obsession with tree mortality. And so yes, this topic can be depressing, but in studying it, our goal is really to understand how to give trees the best chance of surviving. And this is important in a lot of our programs in urban tree planting because the expectation of future ecosystem services is part of the justification for many of those programs. This is a sign, for instance, attached to a tree in the Chicago area saying that this tree will give back a certain amount of dollar value benefits in terms of ecosystem services or environmental benefits over the next 15 years. But what if that tree doesn't survive? Or what if out of 100 trees planted, only half of them make it to a certain point in time, maybe 5 or 10 years after planting? And you could go through similar reasoning whether a planting program does 100, 1,000, or even 1,000,000 trees. And so one of the reasons to study tree mortality is that these assumptions about mortality rates affect the projected benefits of our planting programs. And also from a much more practical management point of view, if we can anticipate the rates of tree death, we can plan ahead for cycles of removal and replacement. And also, if we can analyze the factors that are associated with tree mortality, then we can identify trees that are most at risk and target our program improvements there. And also, if we can identify which planting programs have the absolute best survival, we can figure out what makes them tick and try to emulate their program characteristics. A lot of what I'm talking about here is really urban tree demography. Demography is the statistical study of populations, so it's the same math that's used by actuaries when they're calculating life insurance policies, and the same kind of concepts and analyses that are used by conservation biologists to figure out species extinction risks. And in the urban tree context, urban tree demography involves research on the rates of survival or its flip side, mortality, planting, and also growth. And so the main thing I'm talking about today is a literature review on urban tree mortality. This was sponsored by the ISA and their Science and Research Committee. And so the goals of this lit review were to summarize the reported mortality and survival rates in published studies, determine what rates are typical, and then to identify different factors that had been associated with mortality. We found 56 studies. The earliest one that we could find was in 1979, and we went up through 2017 and did this analysis in 2018. As you can see from this graph, there were a lot more studies published in the early 2000s, really pushing off around 2009, 2010. Essentially, several other folks like myself were studying tree mortality as part of their dissertation work in the 2010s, and that's how we ended up with a whole bunch of studies coming out of us young researchers. So now let's talk about what are mortality rates. I want to kind of take a step back and make sure we're all on the same page about some core concepts here. The annual mortality rate is the proportion of trees dying in a particular year. And it's important to emphasize that this includes both trees that die on their own, so to speak, as well as those that are removed by people, whether the trees were alive or dead. So trees dying, and that includes trees removed by human decisions. And then the annual survival rate. This is the proportion of trees surviving in a given year. And annual mortality and survival are really two sides of the same coin. Annual survival equals 1 minus annual mortality, or stated another way, annual survival plus annual mortality equal 1. Then survivorship is a different concept. This is the proportion of the planting cohort that survives to a particular age. So if I were to say 95% of my trees make it to 2 years. That means survivorship at 2 years post-planting was 95%. And a term that's sometimes thrown around in urban forestry, survivability, actually doesn't have any clear definition, so these other terms are really better to use. So here's what we found from the literature. For each of these kind of study types, I have the number of studies that met that category, and then the median is what you can think of as sort of the middle in the range of the mortality rates that were reported in these different studies. The first quartile is really the lowest mortality that was seen. Third quartile is the higher end. So repeat inventories, by this we mean something like a street tree inventory that was then returned to some years later, and mortality of trees from that original inventory was assessed. Some of those projects were also iTree ecoplots that were repeatedly measured. And then in contrast, planting cohort monitoring is where trees from a specific group of trees planted around the same time, usually by the same program, were tracked, and most of those were in the early years, the establishment phase. And so for a repeat inventory, the typical mortality rate was 2.3 to 2.6% annually. For planting cohort monitoring, it was 4.4 to 6.5%. However, that's also because most of the planting cohort monitoring studies were done in the early years. And so tree mortality on an annual basis, it tends to be quite a bit higher when trees are newly in the ground. And so we took that information about planting cohort monitoring typical mortality rates and turned it into a survivorship curve. And so this is showing you on the x-axis the years since planting, on the y-axis the percent survivorship. So 100% survivorship when the trees are first planted, presumably they're all alive when they get planted, and then as trees die over time, those curves go down. And so the middle curve is that middle of the road survivorship based on the median, and then we have better and worse than normal survivorship. We grade this out to a lighter shade after 20 years to recognize that we really don't have a lot of data for trees 20 plus years since planting, that most of the studies were in the earlier years. So that dashed line is showing you when survivorship is 50%. And so plant population ecologists call that the population half-life. That's when half of the planting cohort has died. So for a typical urban tree planting program, based on this literature review, half of the trees will be dead, half will be still surviving at 13 to 18 years post-planting. In the better case scenario, this better than normal survivorship, it's over 30 years, the population half-life. And for the worse than normal survivorship situation, it's 7 to 10 years population half-life. Now, some of you may have heard this idea that for street trees, the average life expectancy is 7 years. I could give a whole different presentation about why that's more myth than reality. The reality is, again, for a typical urban tree planting program, about half the trees will be dead somewhere around 13 to 18 years after planting. And that's just as true for street trees as it is for yard trees. So factors associated with mortality. This list tells you which different factors were identified by various studies. Species or other taxonomic groupings were listed in about 15 studies. The exact reasoning why one species did better than another was not always identified, although sometimes studies would group things in a more kind of biologically or ecologically relevant way, such as species that are drought tolerant versus those that are not. And then tree size and age. As I already mentioned, when trees are younger, more newly planted, they tend to have higher mortality rates. And so as trees get larger and bigger, mortality tends to decline in general. And then site characteristics, so that included things like the nearby land use. And then for human-related factors, the most frequently mentioned factor was the stewardship or maintenance, or in some cases vandalism. And then socioeconomic characteristics. Although the association here with mortality is very mixed, trees sometimes seem to do worse in terms of mortality in lower socioeconomic status neighborhoods, although that wasn't always the case. And so as we think about urban tree mortality, it's important to reflect on how trees die in more natural forest settings. So you can imagine a national park or a state park or even a natural forest fragment in an urban area. that tree will undergo over sometimes many decades this mortality spiral. Perhaps the tree was already in a sort of less than ideal location in terms of competition. It may have been shaded by other older trees. It might get released from that and asserts dominance if, for instance, one of the older trees gets defoliated and more light starts coming through. The tree might succumb to different forms of defoliation, different insect pests, and it might finally succumb after it's been weakened and had lower vigor from all of these things, from perhaps a fungus at the end of its life, or perhaps a windstorm. And this is all very different from a tree in an urban setting where human interventions at various points can help or harm the tree. And so the tree might have been planted in a stressful kind of planting site. The example we have here is a commercial planting site. It might have different forms of stress on the leaves or the twigs, but that might be ameliorated by expanding the planting pit. If the tree has some sort of fungal attack, that might be assisted by different intervention programs. But then finally, at the end, the tree might actually be removed before it has fully died by a risk assessor who decided that this tree, while still living, is unhealthy enough or not structurally sound enough to retain, that it poses a risk to people or to built structures. And so when we talk about mortality, we really want to think about three different forms. We have the trees that die in place. They end up standing dead from pests, diseases, extreme weather events like storms, perhaps droughts or flooding. And then we have the trees like the one that I just showed in that mortality spiral that die from preemptive health and safety removals. These are trees that were removed because of risk assessments or sometimes to contain the spread of pests or diseases. Sometimes trees are removed to quarantine because a new invasive pest has come in, or because the tree was already deemed to be unhealthy or declining, and best to remove it and then plant a newer, healthier one. Then we have other removals that people do that are completely unrelated to health and safety. So these might be removals of trees that are alive and doing quite well because of construction or human aesthetic preferences or vandalism, or perhaps perceived risk from residents or the general public that doesn't comport with the more professionally assessed risk from trained arborists. And so when we talk about mortality, we should really think about all these three different categories. We sometimes sort of as shorthand say that trees grow in these really stressful urban environments and focus on the sort of biophysical stresses of street trees and sidewalk settings. But actually, quite a lot of tree mortality can be attributed to human choice and things like construction. And so now I want to give a specific example of one of the studies we included in the literature review. This is work that I did when I was working on my dissertation in California. It's about the determinants of establishment survival for yard trees in the Sacramento area. So Sacramento, California is in Northern California. It's inland and it's extremely hot. The temperatures in the summertime are quite often between 90 to 100 degrees. It's a dry heat though, and so the trees absolutely need supplemental irrigation to survive in the summer. And because of all the heat, pretty much every structure there has air conditioning and keeps it cranked up real high in the summer. And so the local utility district, as part of a public relations campaign and also trying to be more environmentally friendly, they sponsor this tree planting initiative for yards. And the whole idea is that these trees will grow, shade the homes, and reduce energy demand. There are quite a few other programs like this that focus on yards as the parts of the urban landscape with the most plantable space, and also quite a few other programs that focus on shade, including an initiative from the Arbor Day Foundation. So here's a bit more about how that program works. Again, the program is funded by the local utility district, and then it's administered by the Sacramento Tree Foundation, who have community foresters that meet with residents and discuss what species to plant and where to plant it, and give them educational materials about how to care for trees and so on. And then the residents themselves do the planting. This will be really critical for what I talk about next. These trees actually get delivered to residential properties, and then people are supposed to right away plant them, take care of them, and they receive copious information about how to do all of that. And so when we were studying this program, it turned out that 15% of the trees were actually not even planted. Now, this might be higher than usual because I happened to start this study at the height of the last economic recession in 2008, and Sacramento was one of the hardest hit areas in the country by the foreclosure crisis. So, this property here is an example of a place that had been foreclosed, was vacant at the time of our visit. You can tell that that lawn is not receiving any irrigation whatsoever. The trees were also not receiving any irrigation. And so the trees not planted problem was associated with homes that were in neighborhoods with lower educational attainment. So when fewer people in the area tended to have bachelor's degrees, those trees tended to fare a bit worse. And also homeowner stability. So what I mean by homeowner stability is properties that were owner occupied and where the home did not experience a home sale or any kind of foreclosure. And so when the properties tended to be less stable, fewer trees were planted. And this homeowner stability thing comes up several more times. Here I'm showing the survivorship curve. Like before, we have time along the x-axis and survivorship along the y-axis. And so at 5 years, there was 71% survivorship, which translates to 6.6% annual mortality. And I sliced and diced and analyzed data a great many ways. And no matter which way I analyzed it, the factor that showed up as most important was this homeowner stability issue. And so here you see the two different survivorship curves for properties that were stable and properties that were unstable. So again, that unstable means properties that were foreclosed, were sold, or were renter occupied. And they tended to have 9.3% annual mortality versus the stable properties, which had 5.2% annual mortality. And really, stable properties much better align with how this program should operate. When the community foresters have that initial conversation with a resident, they're expecting that resident to be the one who controls the yard and who stewards and maintains that yard over the years that the tree's established. If a new resident comes in, or if the property is vacant for some period of time, or if there's some sort of tenant to landlord conflict, then the person receiving the tree is not actually able to care for the tree during its establishment. And I think that the homeowner stability issue is actually a proxy for maintenance. And so this image here shows you one case of really egregious bad maintenance where someone left this nursery stake attached with its tie. It's just slowly girdled that tree over many years. And so in the very first summer after planting, this is what we observed. 25% of the trees were planted in the wrong location. Again, these trees were cited to be in a very specific spot in order to achieve anticipated energy savings over the years. 14% had no irrigation, and that was just based on having a very dry lawn and dry soil in the hot, dry Sacramento suburbs. So probably quite a bit more than that had improper irrigation, but something that we weren't able to adequately kind of assess and assign from a quick field visit. And then 39% of the trees had no mulch. 38% of the trees did not have their nursery stake removed. And actually, one of the program changes that happened based on this research and my collaboration with the Sacramento Tree Foundation is that now when they deliver trees, they always remove the nursery stake. They just remove this as a possibility that residents could get this wrong. And then the support stakes were missing for 22% of the trees, and there were weed whacker wounds at the base of the tree 7% of the time. And the vast majority, 94% of trees that had good maintenance, where residents were really just kind of checking off the bare minimum, like they did have mulch, they did have support stakes, there was some sign of irrigation. It doesn't mean great maintenance, it just means like good basic maintenance. So those were nearly all on your stable properties. And we had some other factors that were associated with higher survival. Stable homeownership, as I already mentioned, and then also drought-tolerant species. So again, getting to this issue of Sacramento having this dry summer. So the rain in California is almost all in the wintertime. And so species that are more drought-tolerant tended to do better, and I think that this is not going to be the case for every planting everywhere in California, but certainly it'll be the case for these residential properties when residents don't always really water their trees. Also, trees that were planted in the rainy season tended to do better. Again, I think this relates directly to the lack of irrigation or sometimes improper irrigation. Trees planted in the front yard tended to do better, and we think that this is because your front yard is more of a showcase for the neighbors, that there's more social pressure to keep your front yard looking good, whereas trees in the backyard might not be as well cared for. And also fewer trees delivered. Most residents in this program only got 1 or 2 or 3 trees, but there were some cases where people could receive up to 10 trees. And even though someone's yard or property might be large enough to receive that many trees, the amount of labor available from the resident or property owner is finite. And so we think that when residents received fewer trees, each individual tree did better simply because there was less labor and effort involved by that resident. So now moving on to examples of high street tree survival. So as I mentioned earlier, sometimes street trees get sort of a bad rap as having these terrible mortality rates, low lifespans, and I want to tell you some stories of how that's not necessarily true, and also how trees planted in neighborhoods of lower socioeconomic status can sometimes thrive, and that it all comes back to stewardship. So the first example is from East Palo Alto. This is a separate municipality from Palo Alto being very wealthy, East Palo Alto more working class. And Canopy is a small nonprofit that does extensive planting in both Palo Alto and East Palo Alto. This particular project were street trees planted in a long planting strip along a highway sound wall and adjacent to a busy road. And the bearded gentleman there with the hat, his name is Dave Muffley. He's a board-certified master arborist, and his involvement with this project was absolutely critical. He's actually now the lead arborist for the new Apple campus out there in Northern California. And when he was working on this project, his decisions about species selection and his contributions, both paid and on a volunteer basis, to making sure these trees were well cared for was absolutely critical. So the 6-year survivorship in this study was 96.3%, which translates to an annual mortality of only 0.6%. And based on our literature review, I can report that this is the best establishment phase survival and lowest establishment phase mortality of any published study. And then West Philadelphia is a neighborhood within Philadelphia, and a tree planting program there is called University City Green. Like the Canopy program in Palo Alto, it's a quite small nonprofit. And the 6-year survivorship here for trees planted around the border of a recreation center, the 6-year survivorship was 90.7%, which translates to annual mortality of 1.6%. And it's not quite as incredibly good as Palo Alto, but it's still pretty amazing. And I want to give you some visuals. This is the street lining, the border lining this recreation center. It's in a neighborhood that's very working class and largely African American. And I mention those things because, again, sometimes socioeconomic status seems to be related to tree mortality, but this shows that that is not necessarily going to predict what happens over time. And so you see the landscape just before the planting and right after the planting. And here's a Google Street View shot showing it just last year, 13 years after planting. The vast majority of these trees have survived. They've absolutely transformed this landscape. They provided shade to all the neighbors and pedestrians in this rec center. So let's talk about those program features for Canopy and University City Green. So they're both tiny nonprofits, only 2 to 3 staff, and yet they were able to really accomplish what sometimes even larger organizations could not, and I think there are several reasons. One is that these trees were concentrated in a small geographic area, so that made taking care of them logistically easier. Not easy by any means. I don't want to make light of the amazing staff and volunteer labor that went into take care of these trees, but I think certainly quite a bit simpler than a program where trees are planted in along streets or in yards or in parks all over the whole city. Just the transportation logistics involved can be quite challenging in those settings. Also, both had paid youth intern programs, and this was absolutely critical. In both instances, the youth internship programs were paid by private foundation dollars that supported green jobs for youth. And then there were closely supervised planting techniques by tree and landscape professionals. consistent and frequent maintenance, and dedicated staff and neighbors, including very strong nonprofit boards with both programs. And actually, in the publication that I did, I have a nice little table summarizing the amount of person hours that went into taking care of these trees. And so if any of you have programs where you're thinking, I'd like to find a way to hire teen summer staff, that information can help you, calculate what you might need. So some conclusions from this research. First, there's a need for realistic mortality projections. Sometimes there can be too much optimism that's not really based in reality when we plant hundreds or thousands or millions of trees and we expect most of them to last long enough to provide environmental benefits and social benefits. And again, that might not be based in reality. On the other hand, when we talk about urban trees do so terribly, or street trees have these terribly low life expectancies, that's not necessarily based in reality either. I think that we don't want to have overly pessimistic or overly optimistic expectations for our planting programs. We should really ground our projections in realism and past data. And then it's important to recognize that tree planting and mortality are part of population cycles in these human-controlled systems. And our literature review findings reflect typical annual mortality rates that can be used to, if you have, similar data for your programs you've collected in-house, you can say, okay, are we in that middle of the road range, or are we higher than normal, lower than normal? And then also, it's critical to recognize that tree mortality includes both the trees that die in place and those that humans remove while they're still alive. That, again, these are human-controlled tree systems. And last but not least, the importance of stewardship for young trees. Because so many of the published studies have been about planting programs and about the establishment phase, we really see this huge influence of proper tree care and maintenance. But there is quite a bit missing actually from the literature. I think that there's great potential for some alternative study approaches. So for instance, mining administrative records about tree removal, or seeing which trees are removed by development. There's the possibility for interviewing decision makers, including arborists and residents, about their decisions, whether it's about how they're caring for young trees or how they're choosing to remove trees. And also, I think there'd be great potential for comparing tree ordinance impacts. So when ordinances restrict private landowners from removing trees, for instance, how is that impacting tree mortality? There are also some factors that are clearly related to long-term tree health and thereby mortality that were missing from the literature. That includes soils. So there's been a lot of work on urban soils, but not really connecting soils to mortality specifically. And then also management response to extreme events. And what I mean by that is not just the trees that die in a storm, but trees that might be removed kind of the season following a storm because the utility company and the residents are now very nervous about the possible damage from trees in future storms. I think that that could be something to investigate through, say, interviews with decision makers. And then I think there's a lot of opportunity to understand resident tree care better. If we have to rely on residents to take care of the trees that are on their properties or adjacent to their properties, then we can try different ways of communicating with folks and doing outreach with folks in ways that would help them better understand how to take care of their trees and just kind of nudge them in the right direction to do that maintenance more regularly. And last but not least, I think research-practice partnerships are critical to all of this. My work generally involves deep collaborations with local nonprofits and municipalities to help understand how their programs work and what can be done better. And I think that that kind of an approach is really critical to make sure that all of this work on tree mortality and related topics isn't just sitting on a shelf in the academic literature, but actually getting out to arborists and urban forest program managers and making sure it can make a difference in those initiatives. I have, of course, lots of collaborators and co-authors and partners to thank. They're listed here. And again, I want to express appreciation for the ISA Science and Research Committee for sponsoring the literature review. This slide is giving a whole bunch of links about resources that attendees today might want to pursue. This includes how to calculate mortality rates, a summary of our literature review in Arboriculture and Urban Forestry, and then a shorter summary in Arborist News. And then new resources that I published with a bunch of colleagues about urban tree monitoring, including protocols for data collection and some training videos. some guidance specific to citizen science, and also any of the studies that I mentioned are on my Forest Service page. So I provided this particular slide as a separate PowerPoint slide for the conference organizers to share with attendees, just to make sure you can click on the links if you do want to follow up with any of that. And in closing, I welcome any questions. Feel free to reach out to me. There's my Forest Service email address. And I hope everybody is staying safe and doing well in these crazy times. I hope that you enjoy your conference.